Well, hello there. What we're looking at today is hypothesis testing. So, this is where someone's got a load of observations. They've done their product moment correlation coefficient calculation using their calculator or however else they may have done it, like we did in the last lesson, and they've found out that the correlation coefficient is negative 0.45. So that's a fairly weak negative coefficient. And the scientist who's done these observations is believing there's no correlation between the masses of the two reactants. So although she's been able to draw a line of best fit, it's all a bit woolly, and so she wants to know whether or not this is just the way that those particular results have fallen out, or whether or not they do look close enough to be able to say, yeah, there's definitely a negative correlation between these two things. So she's got two different reactants, two different sort of, I don't know, chemicals of some sort, certain masses of them being put in, and we need to test at a 10% level of significance for whether or not there is any correlation. So our null hypothesis here would be saying that the probability of these things being connected is 0. It's actually that they're not correlated together, and the alternative hypothesis would be that they are, so that it's not nothing. Because it's not nothing, this means that it could be positive correlation, it could be a negative, even though it's looking like it's negative on there. So when they look for a 10% level of significance, because we're not saying it's more or less, because she's talking about no correlation, we're looking at a two-tailed test. So if there's our bell curve, we're talking about 5% there, 5% there. What we don't know is what the probability of these things being right. So we can't just go into our binomial distribution on it. We need to be looking at this, which means at this point we need to be finding out what the critical values are. So we want to know the critical values of a product moment correlation coefficient. I'm just going to write PMCC for 5% significance, because it's 5% at each end, because it's a double tailed thing. Now that is possible in the calculator, but I'm not going to show you the calculator this time because it's longer, it's more complicated, and we should be getting used to something else in our lives a bit more than we have been recently. And that something is this. Sorry about the fact that I need to get the mirror thing changed over. I can't work out how to do that, but anyway, it looks like this, and it is called the mathematical formulae and statistical tables. This is important because you have it in the exam, as I'm sure you're aware. There are loads of pages in it. Lots of them are to do with further maths, which we don't need. The first few pages, hopefully you're quite familiar with now, but we are looking at page 37, where it says critical values for correlation coefficients at the top. So here we are, critical values for correlation coefficients, and the key things that we don't need to worry about the Spearman's coefficient at the moment. We're looking here, product moment coefficient, level 0.05 is 5% significant, so we're going to be looking down this column, but also our sample size is 30, so we're going to be going all the way down here to where it says 30, and we wanted 5% significance, so that's 0.3061. 10% significance would be just 0.2407, so if we wanted 20% altogether, 10% at each end, it would be that. And then the more significant we want it to be, the closer related it's got to become. So 0.3061 to suggest any correlation at all. So 0.3061. Our equals plus or minus 0.061. So that means down there for your negative, up there for your positive. So what that means is it's got to be more significant than that. So your R value, the more significant it is, the closer it is to 1. So that means our critical region, as it's called, would be when R is bigger than 0.3061 and when R is smaller than negative 0.3061, so closer to negative 1 and therefore being more significant. Now what we've got here is here negative 0.45 is smaller than 0.3061, and that means that that is enough to reject the null hypothesis. So we can say because minus 0.45 is smaller than negative 0.3061, we can reject the null hypothesis, or you can just write HO, as there is enough evidence at 10% level of significance that there is a negative correlation between the masses of the two reactants. And if you wonder where I'm getting my words from, I'm just looking straight back at the question where it says the scientist believes there is no correlation between the masses of the two reactants. So you just need to be clear on that. Okay, that's our first example. Second one coming up. So here is our second example, and this time we haven't been given the product moment correlation coefficient yet, but you've been given a little table of stuff. So if you could pause the video and have a little go and see if you can do that, and then in a moment I'll show you how I get there. So here I'm starting with, there's a load of data in the calculator that I don't want, so if I go to delete all, F1, that gets all of them from one list, go into the other list, delete all of that. So now I can put my data in. So my X is first of all 31, 28, 38, 37, 18, 17, 21 and 29. I should have 8 bits of data. I do. Good. So then go across and 99, 94, 87, 80, 80, 89, 84, 86. So right now I've done that. What do we do next? We go to calculate. I haven't bothered looking at the graph to see if there's any correlation. I'm thinking it quite possibly won't be, because this is about gusts of wind and humidity, and how hard it's blowing. It hasn't necessarily got much to do with how much moisture is in the air. Right, so I'm going for reg, and then X. Doesn't matter which one of these two I pick. My R value is 0.1149. Remember, we want 4 decimal places here, and the reason for that is that's what's always in the books of tables as well, which we just used on the last one, wasn't it? So then the next one's a 4, so that stays at 9. That'll do. So that's part A done. That's all we've got to do, is just that number. And then we're on to part B, testing at the 10% level of significance. Now this time, they want to know if there's an evidence of a positive correlation. So last time, she just wanted to know if there was any correlation. This time, we want to know if it's positive. The null hypothesis is still going to be that probability that we've got no correlation at all. So that would be p equals 0. And our alternative hypothesis is going to be that it's positive, so it's going to be more than 0. Because we're only going for positive, we're not looking for negative. That means we are looking at just a single-tailed 10% test. So now we're going to look in the tables, but before we do, we need to just think about what is our sample size, and that is 8, isn't it? And what else do we need to know? We need to know what is our level of significance. It's 10%, which is 0.1. So if I get my book of values out again, we are going for sample size of 8, and we would want it to be really high if it was going to be for 1% or 0.5% thing, but it's just 10%, so 0.5067 goes with that 8. So 0.5067. So the critical region is going to be bigger than 0.5067. And what did we have? We've only got 0.1149 is significantly smaller than that. So we do not there is insufficient evidence to reject the null hypothesis that there is no correlation between, and what was it we were looking at, a day's maximum gust and its relative humidity. Okay, and that should just about do it. Although looking back here, I'm just thinking I haven't actually mentioned that there's insufficient evidence. I should really have said at the 10% level of significance. At the 10% level of significance. So with all of these things, we never really know for sure whether it's proved anything. We can only say at a different level of significance. And even though we get something where we say, yeah, that is significant, it doesn't necessarily mean it's true either. So we always need to bear that in mind. Anyway, I'm waffling, so I will now tell you what I think we should be doing for practice. So on page 10, exercise 1C, you have a crack at questions 1, 3, 4, 6 and 9, and let me know if you have any problems. Obviously, if you don't have a copy of this, the first thing you need to do before you can do any of this really is come and see me and get one. We've got spare copies. You should have one kicking around somewhere. Okay folks, enjoy that. I will put up the questions and answers for those in a moment as well, and see you next time. Goodbye.